There are different types of reactions that can be written for, especially these like precipitation reactions. So there's molecular equations. The molecular equation is what most people think of as a regular chemical equation. It's going to show the neutral formulas for all of the compounds involved as the reactants and the products. We can also have a complete ionic equation, and this shows more what's actually going on in solution. So it shows any aqueous ionic compounds as ions. When you're writing these equations, only separate the aqueous ionic compounds. So if you have an insoluble ionic compound like lead and chloride, those guys get together, they're stuck to each other. They are not going to separate and mingle at that party. They're off in a dark corner somewhere on the bottom of the beaker, hanging out together. So we don't separate those. Also, if we have anything, so solid, that would include those insoluble compounds. If we have liquids or gases, those are also just written as they are. They don't separate into ions because they're probably molecular compounds. So writing a complete ionic equation, if you see a state symbol AQ, you separate that into its ions. But if you see solid, liquid, or gas, just leave it alone. Write it down as it is. When we look at the complete ionic equation, we sometimes see ions that are the same on both sides. We call those spectator ions. They aren't changed. They're maybe, they came to the party, they're watching this reaction going on between silver and chloride or whatever, but they're not participating in it. It's a little bit like going to a boxing match, and you're sitting in the stands and you're watching these two people beat each other up. Personally, I don't see why that's entertaining, but whatever, to each his own. The spectators don't come out with black eyes and bloody noses, right? They weren't involved, they were watching. So the spectator ions are not actually involved in the chemical reaction, they're just hanging out around the chemical reaction. So to simplify things, we sometimes will just leave the spectators out, because the fight would occur with or without the spectators. The net ionic equation is going to show only the ions that actually participate in the reaction. We use the word species. So it shows only the species that actually participate in the reaction. So species refers to a kind or sort of thing. And what we're using it here to mean is all the different molecules or ions. We get tired of saying molecules or ions. This is kind of long. So we just say species. That includes all of them. So summary of the different types. Molecular equation shows all the neutral formulas for all the compounds. Complete ionic shows all the species as they actually are present in solution. Net ionic equation shows only those things, the species that actually participate. So let's write some. So here's a reaction occurring in aqueous solution. So here's just a side question. Is this a precipitation reaction? How would you tell? What forms in a precipitation reaction? A solid. Is a solid forming here? No, this is not a precipitation reaction. So we're asked to write a complete ionic equation and a net ionic equation for this reaction. Until you get very skilled at this, in order to write a net ionic equation, you need to write the complete ionic equation first. So the complete ionic equation, what we're going to do is we're going to see anything that has AQ, we're going to separate into ions. So here, HBr, this is hydrobromic acid, but acids in water separate into ions. Remember that these can only form two ions. You can't form multiple different ions. So this is H plus and Br minus. So H plus and Br minus. So you can ignore the coefficients and balance it later, or if you just pay a little bit of attention, you can just write it down and not have to balance it again because it's already balanced. If I have 2 of these couples, that means I'm going to get 2 hydrogen ions and 2 bromide ions. So I'm going to get 2 hydrogen ions and 2 bromide ions because I had 2 of these units. Here, CaOH2 aqueous. So I need to separate this into ions. I've got the calcium and I've got the hydroxide. So calcium ion and hydroxide ion. The parentheses in the 2 are telling me I have 2 of those hydroxide ions. That's not part of the formula for hydroxide ion. So paying attention to how many of these, I have 1 calcium and 2 hydroxides. So I want to put a coefficient here. Those are the reactants. And come over here. This is a liquid. Don't separate it into ions, just copy it down to H2O liquid. The last one's aqueous, so I do need to separate it into ions. That's calcium ion and bromide ion. How many calcium ions are represented here? 1. How many bromide ions? 2. So I'm going to put a 2 here. If I check this, I'll see that it is balanced. Any questions? That's the complete ionic equation. To do the net ionic equation, I want to look at these reactants and products and see what didn't change. So here I've got 2 hydrogen ions as a reactant. Do I have 2 hydrogen ions over here? No. Those H's went into the water. They formed something new. So those aren't spectators. What about 2Br minus? 2Br minus. Nothing happened to the 2 bromide ions. They're just watching. Those are spectators. So for the net ionic equation, just cross those off. What about calcium ion? Nothing happened to calcium. He's a spectator. What about hydroxide? Do I see hydroxide over here? No. So I crossed off the things that are the same on both sides, and then I'm just going to copy down what's left. 2H plus aqueous plus 2OH minus aqueous, forming 2H2O liquid. That's the net ionic equation. What could we do to make that just a smidge better? Balanced chemical equations should have the lowest ratio of whole number coefficients. I've got 2, 2, and 2. I could divide all the coefficients by 2 and it would still be balanced, right? So I'm just going to get rid of those. So hydrogen ion plus hydroxide ion forms water. That's the net ionic equation. Any questions? Yeah.
Why did you cross out the I can't see a...
Because I have 2 bromides here, and I have 2 bromides over here. So she came to the party, didn't hit it off with anybody, and just left again. Didn't get into a relationship. Hydrogen and hydroxide got into a relationship. Calcium and bromide showed up, and nothing happened. Any other questions?